Hey, how's it going, everybody? So today we're gonna be putting up a GNS3 topology, and we'll be working with JunOS. Specifically, we're gonna be using this QM that I have here. It's called June Olive, and let me show you the settings real quick. Mm. So I given it 1 GB of memory and 4 network adapters, so you can see. So if you're like me and you come from Cisco world, if you wanna get into Juniper, this is gonna be a good video for that. I'll be showing you how to set up basic routing in JunOS. We'll be using RIP as well as OSPF and some BGP. And that pretty much covers the first exam from Juniper, the JNCIA or JunOS exam. And so let me throw this in and let me pause the video while I do this. Alright, so this is what we're gonna do. And I'm gonna take a screenshot and here. So we're gonna be running RIP on this side of the network, and then we're gonna have OSPF over here, and this is gonna be our redistribution point, and it's gonna be BGP down here, and we're gonna do um, IBGP and EBGP. Okay, so and what I did here is this is Ether switch. It's basically a 3725 with a Ether switch module, and I have it connected or I have it bridged to my physical network, which is my VLAN 100, and it's the 192.168.0.0/24. So let's go ahead and start this up and give it some time. Alright, and while my routers are booting, I think I forgot to show you the um, the image for this particular device is, let me see, not that. Okay. Alright, so most likely if you find your way to the image, you're gonna download it as an OVA file. So basically what you're gonna do is that you want to extract the VNDK file or the hard drive file, and then you want to convert it to QCOW2 just so you can put it in your GNS3. And the way you do that is that you gotta download the QEMU, and then basically you do something like this. And so it's gonna be QM and dash O. That's the output that we want to have. We want to have it in QCOW2, and then you specify the name, and then the output name. And let's just say I'm gonna call it. That's basically what you do. And as you can see, you have the output file right here. So there's that. Let's take a look at our machines. Okay. Alright, so I renamed the tags, the tabs 1 through 7. And then if you see this keyword right here, it says Amnesiac. That means the router is in its default config or the factory default. So you want to log into it using root, no password, and we go ahead and do that. All of them. Um, so we're gonna do this. Um, so we're gonna use this feature. We're gonna send some basic comments to all the routers. That'll put us in that CLI. That'll put you up in the operational mode, and it is indicated by the greater than sign symbol right here. And then we're gonna go into edit. And first thing you want to do, um, get this out of the way. Okay. All right. So the first thing you want to do is that you want to set up a root password. Because if you don't, it won't let you commit any changes. Like if you try to set system host name, and we're gonna call this one Olive1, and you try to commit to that, it's gonna tell you that you don't have you're missing the root authentication password. So let's do that real quick on all machines, and um, you do set system root authentication, and it's gonna be a plain text password. And now you put your password. Gonna call it lat123, or I think it's gonna be ASD1234. AC123, AC123. Okay, and we're gonna commit that. Okay, let's see. Okay, so let's look at some basic stuff. Um, this config mode it will be the equivalent to the um, configuration mode in iOS, and so basically you navigate through the different levels of the hierarchy between using the edit command. So if you want to edit the interfaces, you do this, and then you can go to the top of the tree using top, and that will put you back in the main at the main level. And then if you want to go back, you do exit. We have some uncommitted changes. No, or yes. Okay, and this is the operational mode. So from here you be throwing all your show commands. Like if we wanna see our interfaces, and this one will be the equivalent to the show IP interface brief. So we're gonna do show interfaces first. Okay, and these right here are gonna be our interfaces, the ones that we're gonna be using. Um, so let's go ahead and get some IPs on all these interfaces. And we'll do that by going to edit, and we're gonna set interface 0, and it's gonna be the unit 0. And that unit 0 is basically like a sub interface when it comes to iOS. Um, and it's gonna be family inet. That's let me inet, and as you can see here, it's for IP4. So we're gonna say inet, and the address is gonna be 10.0.12.1/24. And we're also gonna be having some. Let me bring this up. We're gonna be putting some loopback interfaces. Actually, we're gonna use just one. It's gonna be 1.1.1.1, and over here it's gonna be 5.5.5.5. And then I guess we'll do one more here and one more here. Okay. So set interface loop at 0, unit 0, family inet address 1.1.1. It's gonna say /32 and commit. Okay. And in fact, actually, I'm just gonna pause the video while I give the IPs to all of them. Just give me a few minutes. Alright, so now all the interfaces have um, their corresponding IPs, and we can verify that using the show interface strs. And if you want to do it in the configuration mode, you can do it by using the run command. So you do run show interface strs. That will show you the interfaces. So as you can see, the all the IPs are mapped to the interfaces. Okay, so let's take a look at how we're gonna implement the RIP over here on over this side of the topology, and we're gonna work our way over to the right and then going down here. So let's go on the protocols menu and protocols RIP, and we're gonna say set, and then let's see, we're gonna have to define a group, and we're gonna call it RIP group. Okay, and then we're gonna say neighbor, and it's gonna be the interface that's coming out from this router, so it's gonna be the EM0. Okay, now when it comes to RIP in JunOS, by default the router is not gonna advertise any routes, so we gotta have a way to tell it to go ahead and advertise the routes, and we do that by leveraging this things called routing policies. So let's take a look at that. And it's under the edit routing policies, or actually um, policy options, and then policy statement. And we're gonna have to name it, and it's gonna be export rip, and then okay, so we have these three keywords: from, term, and then. So basically, we're gonna tell RIP, or we're gonna tell this router, let's create a term. It's gonna be term one, and from protocol connected, or protocol. Let's see, direct, and then so from protocol direct and set term one, then um, accept. Okay, and let's go back to our edit protocols rep and set export, or set group rep group export, and the policy that we just created, and we're gonna say commit, or commit. And let's do a show. Alright, so basically what we did, as you can see here, we created a policy option, or a policy statement called export rip, and then from we define term number one, and it's saying from protocol direct, meaning everything that has every directly connected interface is going to be matched to this term one, and then if it matches, then accept it. And so if you see over here the protocols rip, so we decided to export that policy statement, and it's right here, export rip. Okay, so let's go ahead and create the adjacency between these two. Okay, sorry about that. Apparently the router 2 glitched on me or something, so I had to reset it. So let's go back to our edit protocols rip, and we're gonna say set group rip group and neighbor eno dot oh that 0 and command. All right, so now we should be able to see the uh, look back interface over at router 1, and there it is. Okay, so now let's say 0.1, that will create the adjacency, or actually go over here in protocols group rip group, and we're gonna say neighbor. Okay, so now we need to tell router 2 that he needs we need to tell router 2 that he needs to export the routes over to router 3, and that's we're gonna be doing the same thing. We're gonna create a um, policy statement and um, up up and edit policy options policy statement. We're gonna call it export rep. We're gonna create a term or term 1, and it's gonna be front, and this time we're gonna match using protocol rep, and or actually yes, we're gonna say rep and connected or direct. Okay, and then if it matches, we're gonna accept, or sorry. Okay, commit to that. Okay, so now we should be able to see hmm, let's see what's going on. Oh, of course. So set protocols rip and group rip group, and we're gonna say export rip. Right. Okay, so there it is. And can we ping? Yes, we can. All right, so now let's jump over to router 5 and see how the OSPF plays out. So we're gonna say, and before we do that, let me show you the when it comes to debugging in JunOS. Basically, this is what we would do. Set protocols OSPF, and it's called trace options. So you're gonna say trace options and file, and this is the name of the file you wanna save your OSPF debugging. So we're gonna call it OSPF debug, and it will. And let me show you. Uh, Exit with uncommitted changes. No, command, please. Okay. So the debugging files or the trace options files will be saved. Let's see if I remember. It was um, var and log. Yes. Okay, so if you can see, here's our file that we just created and matched to our OSPF debugging output. So when you when you're troubleshooting, and then you might want to come back to this file to see what's going on. All right. So config mode, and we're gonna say set protocols OSPF, and we're gonna say area 0 or 000, and then interface we want to activate the OSPF instance, so we're at EN3.0 interface, and yes, that's it. Say commit, and let's go over to router 4, do the same thing. OSPF areas, oops, sorry, set protocols OSPF area 000, interface EN3.0, and commit. And while we're here, we're gonna do the same thing for interface EN2.0, which is right here, and commit. Alright, so now we should have an adjacency between these two, and let's confirm that with go back here and show OSPF neighbors, and there it is. Now OSPF by default it will export the every route that it has without having to specify a routing policy or a policy statement. So actually we forgot to activate we forgot to advertise the loopback from router 5. So let's say set protocol, so FPF area 0 and interface loopback 0.0, and we're gonna say, let's see, where is it, passive, because we don't wanna run OSPF over the interface, we just wanna advertise it. So say commit and create the adjacency between these two. Set, oops, sorry, set protocol, so FPF area interface. Alright, so now that that's done, we want to, let's see. So we got the read portion over this side, it's done, and this OSPF part is also done. So let's just go ahead and focus on router 3 right now, and we're gonna wanna have a routing policy saying that all that's coming from the RIP protocol, we wanna advertise it to the OSPF domain, and the same thing for the other way around. So let's do that right now. Alright, so let's see what we have here. Okay. Alright, so let's go ahead and say edit policy options and policy statement, and we're gonna call it export, or actually we're gonna call it RIP to OSPF, and we're gonna set a term called term1, and we're gonna match protocol RIP and direct, yes, and term1, and then we're gonna match, we're gonna accept, say commit, and top, and go under edit protocols OSPF, and we're gonna say set, and if you see right here, we're gonna set an export policy called the one that we just made, rip to OSPF, and that's it. Commit. Okay, let's do the same thing for the in order to be able to export the OSPF routes into RIP. So exit out here, and we're gonna edit policy options, policy statement, and we're gonna call it RIP or OSPF to RIP, and set turn 1 from protocol OSPF accept, and then we're gonna say set protocols RIP group 1 or RIP group, and export. It's gonna be OSPF to RIP, and we're gonna say command. All right, so now we should be able to ping. Excuse me. Now we should be able to ping the look back for router 5 from router 1, and let's verify that. Show route, and here's our route, and let's try to ping it. Yes. All right, so let me see. All right, so we got all these parts situated. Um, so now we're gonna focus on BGP, IBGP, and EBGP. So let's take a look at that. We're gonna go over router 6, and we're gonna say edit protocols BGP, or actually we're gonna say first set routing options, and the autonomous system, we're gonna call it this is gonna, let's see, this is gonna be the IBGP. So alright, so yeah, so router 6 is gonna have the same autonomous system as router 3. So we're gonna say autonomous system 36. Okay. Alright, so exit out of here. Oops. No, sorry. Alright, so set protocols BGP, or BGP, and then oops, edit protocols BGP. Okay. Alright, so we wanna set a group, and we're gonna call it group 36, and it's gonna be type and internal. Okay, and then after that we're gonna say set set group 36, and we're gonna say neighbor, and we're gonna we're gonna use the same IPs from the interfaces to create the adjacencies. So it's gonna be 192.168.36.3. Okay, and let's commit. Okay, so if we see now, show BGP, we shouldn't have any neighbors, or okay. So the state is, as you can see, it's active, meaning we haven't established an adjacency, so it's actively trying to do that. Um, so let's go over to router 3 and say set routing options, autonomous system, and 36. And let's see, edit protocols BGP, set group 36, and it's gonna be type internal, and set group 36 neighbor, and it's gonna be 192.168.36.6, and command. and set group. You know what? I think we forgot to yes, let's group 36 and let's see, it's local address, and we gotta specify our the local address that we want to use to establish the adjacency. So we're gonna say, because we're at router 3 192.168.36.3 and commit, and let's do that in router 6 and local address and commit. Okay, so let's see, exit, show BGP summary, active input packets. Let me see something. All right, so as you can see, uh, now we're starting to get some input and output packets out of the adjacency or the neighborship, and we no longer have the active keyword down here. So that's a good thing. So let's go ahead and create the adjacency between these two, the external one, and then after that we'll take care of um, the routing policies. So let's go over to router 7 and say set routing options, autonomous system, and we're gonna say this one's gonna be 7 and edit protocols BGP, and we're gonna set a group. It's gonna be group 37, type external. Okay, so there's that, and let's see, set group group 37 and peer autonomous system. It's gonna be the autonomous system from router 3, which was 36, and then let's say neighbor. Neighbor is, yes, 192.168 37. I can that 3. Okay, and our local address is gonna be 92.68 37 7. All right, so that looks good. And let's let's go do the same thing over at router 3. Edit protocols, BGP, set group 37, and type external, remote A. Huh. Uh, let's see. Oops. Oh, PRAS. Okay. And it was AS7. Set group 37. Local address and commit. And let's see if we're not missing anything. You can do a show protocols BGP. Alright, so we have our two groups. One is the internal and the other one's the external. So let's see, external, we have type external, PRAS, local address. Oh, and okay, we're missing the neighborship statement. I mean the neighbor statement. So set protocols BGP group 37. Alright, sorry about that. My bro just walked into a room. So BGP group 37 and neighbor. It's gonna be 192.168.37.7 and commit. And let's verify our configuration here. Show protocols BGP. Type external local PRS neighbor. Okay, that looks good. So router 3. Okay. Alright, so let's do show BGP summary. And okay, that looks good. So let me bring this up. Alright, so the default behavior of BGP is the same as basically the same as RIP. So BGP won't advertise anything unless you tell it to. So we're gonna say on router 3, um, we're gonna tell router 3 to advertise everything he knows about any route over to router 6 and router 7, and we'll do that with our routing policy. And then in router 6 and 7, we're gonna tell them to advertise the local loopbacks that they have. Okay, so let's do that real quick. And over at router 3, we're gonna say edit um, policy options, policy statement, and we're gonna call it export all. So set term 1, and well, because we want to match everything, we're not gonna say from, so we're gonna go ahead and say then accept. Okay, so let's see how that looks. Let's see. Okay, so we have our three policy statements. This one, as you remember, this one's advertising RIP into OSPF. This one's advertising OSPF into RIP, and you're gonna use this one to advertise everything into the BGP domain. So as you can see, it's missing the from statement. That basically means it's gonna match everything. Basically means it's gonna match everything. So let's go over to edit protocols BGP, and we're gonna say set group 36, or I think we can, let me see, set export, yes, set export, and we're gonna say export all, and let's say commit. Alright, so just do the same thing here. Edit policy options, policy statement, export loopback or loop, or actually, because we want to advertise, we also want to advertise this subnet right here, which is my local subnet. We're gonna say, let's see, export. I say export all, and set term 1. We're gonna omit the matching the matching statement. We're not gonna have any from statement, so it's gonna be then accept. Okay, and okay, so set protocols BGP export all, and commit. Do the same thing here. Policy options, policy statement, export all, set term 1, then accept, and set protocols. Oops. Set protocols BGP export all, and commit. Alright, so now we should be able to see these two loopbacks from router 3, from router 1, well, as well as from router 3, and let's say show run, show route, and we're still not getting the let me see right here. Okay, so we're seeing the two lookbacks from router 3, and the reason that we're unable to see them from router 1 or all these other routers is because um, we haven't redistributed BGP into RIP or into OSPF, so we're gonna go ahead and do that right now, and we can do that by, let me see, show policy options. Alright, so let's see. So we're gonna add in the term one, in the two policy statements, we're gonna add the BGP into this statement right here. We're gonna add BGP, so that'll match the BGP routes too. So that's what we're gonna do. And let's see, let's gonna say set policy statement or policy options policy statement, and then OSPF to RIP, and term one, we're gonna say from protocol, and we're gonna say direct and BGP. Okay, and let's do the same thing for RIP to OSPF. Okay, or actually RIP to OSPF. We're missing the yes, it's RIP. Okay, so say commit. Let's see how that looks. Show policy, or oops, so show policy. Mm, OS, OSPF to RIP, OSPF direct BGP. Okay, so that's fine. Alright, so we should be able to see the loopbacks now, and we do. And okay, so that looks good. Now, if you can see 192.168.0.0, this be let's see 10.0.12.2. Okay. Alright, like if we go over to router 3 and say run show route, and this network right here, as you can see, we have two different ways to get there. Um, we can get there through router 6 or through router 7, and if you notice, you see they both have the same administrative distance, and it's 170. Um, so if you recall, when it comes to BGP in Cisco, the internal BGP and external BGP, they have different ADs. If I'm not wrong, the internal BGP it's gonna have administrative distance of 170, and the external BGP is gonna have 20 as the AD. Um, but when it comes to JunOS, they both have the same. They both have the same AD. All right, so let's see what else can we do here. Um, well, I guess that's all I wanted to show you for now. So that pretty much covers what it is, the basic routing stuff when it comes to JunOS. And we're like 45 minutes into this video, so I'm gonna just cut it off right here. I hope this has been informative for you, and I'd like to thank you for viewing.